Hello everyone, I welcome you all for today's session on machine learning with Python. Module 3, Artificial Neural Network, Lecture 2. I am your friend Mahadevas, Assistant Professor, Department of ENC, GHOUSIA College of Engineering, Ramanagaram. Before going to the detail, subscribe to my channel, click on the bell icon for further notification, or share with your friends for their benefits. First, let us see the content. In today, we'll be concentrating on types of networks and neural network representation. First, let us see the types of network architecture here. Here we are studying basically on three important concepts there. There is about single layer feed forward network. Second one is multi-layer feed forward network. Third one is recurrent or feedback network. Let us see in detail. First, single layer feed forward network. Here in this, we are having two important layers. One is input layer, another one is output layer. So this is the input layer and this one is the output neural layer there. In this, the input performs no computation is performed here. So input is not performing any computation, whereas the output layer is performing a cumulative sum operation of each nodes from the input layer. As we already know that each nodes are interconnected here, and this output node just performs the cumulative operations received from the input layer there. So the information always flow in a single direction. That's why it is also called as unidirectional feed forward network, which is from the input layer to the output layer. Second one, what we have is multi-layer feed forward network. As we can see here, the architecture in neural network, here it has a multiple layer composed of one input layer and more than one hidden layers there. So one more what we have is the output layer. As you can observe here, an example of one hidden layer and two hidden layers in the particular figure shown here. So there exists more than one hidden layer. So the network to be computational layers. Since the more than competent, that is the hidden layers are present, computationally they are stronger feed forward network because the information passes through the input functions and the input intermediate computations used to define the output layer. So as we all know, the important computation is performed in the hidden layer, and this operation performed on the hidden layer passes the information to the output layer there, and there is no feedback present in this. So there are no feedback connection in which the output of the models are fed back to itself there. So that's why we call it as multi-layer feed forward network, because it is moving only in one direction. And this next one, what we have is about recurrent network or a feedback network. So in this, we can observe the output of the neuron are connected back to the inputs with the help of a feedback. As we can see in the figure, there is a one feedback network connected in the figure there, where the output of the neuron are fed back to the input of the other neuron. So recurrent networks are feedback networks with a closed loop, as we can say there. There are two types. One is single layer, another one is multi-layer, which we'll study it in the future. Now, next concentrate on the neural network representation. So here, how this neural network is representation is well understood by one of the important example presented by Pomerello system called as Alvin. So in which we can see an autonomous vehicle driving at a normal speed in the public highway there. How this vehicle is traveled automatically in the particular highway path. So here we can take that the input is having reading the image of 30 cross 32 grid pixels. As we know, the images are represented in terms of pixels there with help of a sensor called as camera. So the input to the neural network is 30 cross 32 grid pixels intensity obtained from a feed forward pointed camera mounted on the vehicle. As we can observe in the figure there, the network output is the direction in which the vehicle is traversed. As the image is captured with the help of the camera here placed on the vehicle, okay, and the output is what? How the direction of the steering has to be maintained there. So here you can observe the figure which illustrates the neural network representation. The network shown in the input camera is the image depicted below here, as we can observe it. So the each node, that is the circle, what you can observe in the network diagram, corresponds to the output of a single network unit. And the line entering the node from below are all its input layers there. Okay. So there are 4 units that receives the input directly from the 30 cross 32 pixels. As you can see, this is the image of the road captured by the camera, and all the images that of the pixel capacity 30 cross 32 is being receiving as an input to the hidden layer there. And these are called as hidden unit because their output is available only within the network and is not available to the global output. So that's why they are present in the hidden unit. So each of these 4 hidden unit computes a single real valued output based on the weighted combination of its 960 inputs. As you can see, this particular image is consisting of 960 inputs. Okay, it's a weighted sum combination is given to the hidden unit, and the computation is performed, which is given to the respective output unit, as we can show it here, showing the sharp left, straight ahead, and the sharp right. So this hidden unit outputs are then used as an input with the second layer of 30 output units. As you can observe, the output we have is 30 units. So each output unit, what it performs is corresponds to the steering direction, and the output vehicle of these unit determine which steering direction is to be recommended most strongly there, either left, right, or a straight ahead. So as you can see, the figure depicts the learned weighted values associated with one of the 4 hidden units in the ANN layer. And this is the result of the ANN network obtained with the help of a hidden units there. So the large matrix here with the help of black and white on the lower depicts the weights from 30 cross 32 pixels input to the hidden. So these box or the matrix are the input to the hidden units. However, this black and white box are represented as a black box as a negative and a white box as a positive weight, and the size of the box indicates the net weighted magnitude. So as we see, it's the cumulative operations of the input signals received to the hidden unit from the input images of 960 inputs. The smaller rectangular diagram, what you can observe here at the top, shows the weight from the hidden output, that's the hidden unit, to each of the 30 output units. So whatever the single layer is we have is the hidden unit output, which is in white indicates the direction that's which is positive weight and which is negative weight, in which direction the vehicle has to travel there, as the ANN unit performs the decision there, either true or false, in the which direction it has to travel. So this is how a neural network representation can be used for representation by considering one example of all-wheel vehicle travel, that is automatic vehicle travel in the highway there. Now let us see where are all the neural network problems can be used. So in an artificial neural network, learning is well suited to the problems in which the training data corresponds to a noisy, complex data, and such as inputs from camera and microphones. And this, especially the ANN network, is especially useful where the sensors data are too much. The second one is that what we have is back propagation algorithm, the most commonly used in ANN learning technique, and it is appropriate for the problems with the help of the following characteristics. So wherever these following characteristics are present, the ANN network can be used. One is the instance are presented by many attribute values. Now wherever the input values are having many attribute values, in such cases we can use this ANN. So instance are represented by many attributes. So the arrow function to be learned is defined over the instance that can be described by vector of predefined features such as pixel values and the all-win examples. As we can see in the all-win example, how the pixel values are used because we have 960 inputs where the large number of inputs are present. So at that time, this ANN plays an important role in identifying which direction the steering has to be carried out. The second one is a target function. Output may be discrete valued or a real valued or a vector of several real or a discrete value attributes. So this particular ANN can also be suited for a discrete valued or a real examples, or wherever the real valued sequence with the help of vectored inputs. At that time, we can be using this particular ANN algorithm. A simple example we can say is that we can train a single network to output both the steering command and the suggested acceleration. So especially in Alvin, we can see in which direction it has to control. We have to use the direction of the steering command there with the help of an accelerator by considering the input image captured by the camera camera there. So simply concatenating all these vectors that encode these two output predictions. So by seeing the image, we can predict in which direction the vehicle has to travel. The third one is the training example may contain error. Sometimes the training example may contain error. At that time also we can use this ANN algorithm. So ANN learning methods are quite robust to the noise. Fourth one where the long training times are acceptable. That's in the we can see automatic driving vehicle. It requires a large number of input to be stored in the memory there, because a vehicle has to travel in a proper direction when with unmanned means a large number of training example has to be given in the processor there. So to do that, this particular algorithm can be used. A network training algorithm typically requires longer training time than say decision tree algorithm. Another one is fast evaluation of the learned target function may be required. So automatic learning and fast evaluation is most important, as we can see in all-wing vehicle travel, automatic vehicle movements, where we can see a real-time examples, such as in ANN learning times are relatively long. Evaluating the learned network in order to apply to a subsequent instance is typically very fast, because sudden decision has to be taken when traveling, when we are making a vehicle travel in one direction there. So at that time, the CNN network can also be used. The ability of the humans to understand the learned target function is not important there. That the weights learned by the neural networks are often difficult for the humans to interpret. A sudden movement in the vehicle, it becomes difficult for the human to interpret that. So at that time, we can make use of the CNN network to take the decision there. So these are some of the problems where we can use the artificial neural network example for the solutions. If you have any questions, go to the comment section, write down your questions. I will reply to your question. Or subscribe to my channel, click on the bell icon for further notifications, or share with your friends for the benefits. Thank you.